Today, in Ibaraki, Japan, Fujifilm are making next-generation lenses to capture 4K video with 4 times more detail than regular high definition. Nobuaki Toyama is Fujifilm's optics guru.
4K レンズとは、3つのハイを満足するレンズのことを言ってます。ハイレゾリューション、ハイコントラスト、ハイダイナミックレンジの3つを満足することで、より目で見たままを映すことができる、HD と比べてより臨場感のある撮影をすることができます。
The screen of any digital device is divided into hundreds of thousands or even millions of pixels. Full HD uses 2 million pixels, but 4K uses 4 times that amount, 8 million. The more pixels used to represent an image, the clearer and closer it will be to the original. One of the hardest things for any camera to film is live sport. They have to capture high-speed motion in low light and from far away. Fortunately, the state-of-the-art box lens has it all covered. Advanced cameras use multiple glass elements inside. These work together to focus the light onto a sensor, creating images. So all the lenses need to be perfectly curved and free from aberrations to minimize distortion. Getting the correct curvature on the lens is the first step. A pre-cut disc of rough convex glass is placed under a diamond cutting wheel. The machine grinds the perfect curvature to the nearest thousandth of a millimeter. The glass is now shaped, but it's still not smooth enough. So it's time to take a spin on what's called a grinding shell. A spinning disc covered in grain pellets. A mechanical arm moves the lenses back and forth to smooth the glass to the nearest fraction of 1,000th of a millimeter. But perfectionist polisher Atsushi Hiroki isn't done yet.
まず研磨工程で求められるのはまず表面の粗さ、外観をいかにレンズの表面きれいに仕上げるかというのが一つと、やはり面精度をしっかり規格内のものを作るっていうのが大前提で行われます。
The lens is then fixed to an arm, which rubs it side to side over a polishing plate. A secret blend of superfine polishing agents hones the lens surface to the nearest millionth of a millimeter. That's half the width of a strand of human DNA. After hours of polishing, it's ready for an inspection, and there's no substitute for the expert eye.
そこはやはりね、最終的に全ての条件がマッチして、レンズって出来上がるんですけども、それが出来上がった時の喜びというか達成感っていうのはずっと苦労してもその苦労っていうのは一瞬にして忘れてしまうような。
The lens is perfectly polished, but it's not broadcast ready. When light hits the surface of an ordinary glass lens, 4% bounces off. These stray rays can cause reduced contrast and flare. So they solve the problem with multiple layers of an anti-reflective coating. It all happens in what looks like the inside of a space capsule. But in fact, this is a purpose-built vacuum chamber. First, the lenses are mounted on round racks called planets. Then granules of metal compound resins are loaded in. Once the lenses are in, the door is closed and the planets start their orbit. Inside, an electron beam evaporates the coating materials. The vapor rises and settles on the lenses, giving them an anti-reflective layer. The machine coats the front and rear of the lens, but straight light rays could still sneak in the side, creating flare. To block unwanted beams, they apply a thin layer of optical paint to the outside of the lens, which acts as a light blocker. Finally, the lenses get one last clean, and all the parts are assembled by hand. All that's left is a few small optical adjustments. And the box lens is ready to capture TV pictures so clear you'll think you're sat in the front row.